In this video, I will be explaining how to control a servo motor with a Raspberry Pi 4 in Python 3. First, you will need a full Raspberry Pi 4 with all the connections and internet. And on that Raspberry Pi, you will need the VNC enabled on it. To enable VNC, you will need to type you need to go to the Raspberry Pi symbol, Preferences, and Raspberry Pi configuration. Then in Interfaces, enable VNC right here, or you can just enable all of them. So once it is running, what we need to do is go to Overview of Adafruit, and here is the link, and all the links for the videos and websites will be posted in the description. So go to the Adafruit website, hit the next button until you reach to the code. And this is very important. So duplicate that page. You will need that also for the code. Then, once you are on the Python example line, you will see two things. The only thing you'll need is this part. So, copy the code by clicking the button right here. What it's just doing is you're importing a package called time, which is used for telling the time and also for counting seconds. And this is the package made by Adafruit, which is wire in Pi. So I guess it's for GPIO pins for the Raspberry Pi. First, you see is the wiring Pi setup GPIO. It's setting up the GPIO pins so you connect things to them. And this line of code does wiring Pi pin mode 18, wiring GPIO PWM out. That means it's setting pin 18 on the Raspberry Pi it's setting it for the signal pin for the servo motor. We will be using this servo motor. It's the MG90's micro servo motor. It has 3 pins, as you can see. The brown one is for negative, the red one is for positive, and the orange one is for signal. You will need all of these pins if you want the servo motor to work. So, hit the new window and type Raspberry Pi GPIO pins. Enter. Hit the images and click on the one that you see. It kind of looks like this. As you can see, the yellow ones are GPIO, which we are using for signal. The ground is for the negative for the servo motor, and the orange ones are 3.3 volts, which are for other devices, and the 5 volts we are using for the servo motor. So if you want to see 18, which is here, it's a GPIO pin. So once that is done, we can get to the coding part. So we will need this for also the code. We will be creating an application to control the servo motor. Before you do anything, get your servo motor and then get your Raspberry Pi. Once your Raspberry Pi is here, open it up, open the lid up. As you can see, there will be many GPIO pins, but as you can as you can see here, the 3 wires, the signal, which is this one, the red, which is this one, and the negative, which is this one. So get your Raspberry Pi and connect the red one to the signal right here, and connect your negative one 2 pins upward, 1 pin upward to the red pin. Then get your this is what I'm talking about. This is the red pin where we connected the ground pin, and it will be 2 pins more. So for the signal, so get your signal and go 3 pins. As you can see, we have finished the connection, and if you want to be sure it works, you can make one of these papers that say 0, 45, 90, 120, and 180. For this video, we will be doing this project for 120 degrees. If your Raspberry Pi gets hot, you can get the Cana kit, which has this little fan on the bottom of the lid. So that's the only one. There's two 5-volt pins, so you can move your servo motor pin and put your fan 5 volts one in. Then get your ground and place it on the opposite side and put it 5 steps from the first one. Then your fan should make the fan sound that it usually does. Once that is done, you can put the wires aside from your Raspberry Pi. Then go to your code, and what this code does is it's just simple. It actually does nothing except one thing. So what we're going to do is from ticker tick initer, that package is pre-made with Python. From ticker import all, which is the star, which is uppercase 8. Yeah. So then we will need to do is window, a variable window equal to shift tk, then curly brackets. Brackets. Then b1 equals to button window text 1. So b1 dot gray row 1 and row column 1. b6, which is button 6, is the close button. So if we save it first and run it, nothing happens except this little tiny window. If we hit 1, nothing happens. If we hit close window, nothing happens either. So the first thing we'll need to do is create some create some functions. So def, we'll do the first one as close window. Then we can just hit print closing window. Then we can type exit. Then we can type another one. That says deg1. Then we can give in here, if we don't know a command and we need that command, you can just go to pip, the name of this package, copy it and paste it. Wait. Copy it. It seems like you won't copy it. So let's just type it. So go to the home page of pip, which stands for Python Package Interpreter. So we can we found what we needed, which is the command button. We'll need the command. is equal to is equal to deg 1. We don't give the ending of the function because that's how this package works. Then make sure you have a comma after the column. Then save it, then run it. It seems something has happened to it. So the mistake was we're supposed to do that on the first line. Save that and it should work. See, so if I hit 1, let's run this in the terminal. Sudo python 3 main 4.py. Enter. If you hit the 1, it should print. If you click the 1 prints out. The close window works good. So if we click 1, it's going to print at 1, but we want to control the servo motor along. So the close window button works fine. So now what we can do is go to the Adafruit website and to the coding page and copy that code, then go back to Tony, then at the end paste that code. Now we have some things we need to do. So you don't need that time function. Package. Copy all of these things on the first besides delay period. Then paste them in the middle of those. Then so once we done that, we can copy the pulse, the 4 pulse in range 50 to 250 and paste it in the deg 1. Then you can delete that code. Then once that is done, it should be working fine. Here's our servo motor. So as you can see, it works good. So let's add a few more degrees besides 1. We will need this page this time. The servo motor pulse. So as you can see, for this is 100, which is the first one. Then the second one is 150. Then the third one is 200. So what we can do is we can copy that function 4 times. Paste. Then rename each one to their specific numbers. Then change the print variable to Then for the pulse, we will go to we would go. So let's start out 0, 0 to 100, 100 to 150. Then 150 to 200. Let's test this out. Also, before you need to do any of those things, we forgot to create those buttons for the application. Copy the buttons 4 times. Then you will need each one to be different numbers. Then we'll change the column to this to be 2, this to be 3, and this to be 4. 4, 3, 2, 3, and 4. Type it again. 1 is so as you can see. So as you can see, it kind of worked. So So the only thing we need to do now is go back to Tony, go to 4, and change this to -0 to 200. And also, it seems like we had to change the pulse of 3 and 1. Save it, go back to the terminal, enter it, then let's test it. 1 is 0, that's good. 2 is 45, that's good. 3 is 90, which is also good. And 4 seems to not be working at 0. It seems like this has to be 50. And it seems like 4. It seems like 4 is still not working. Oh yeah, so what we need to do here is we have to reverse the numbers this time, because we're going it to a negative number. We're going it to a negative side, so it should be working now. Oh, okay, so it actually works. 1, 0, 2, 45, 3, 90, and 4, and close. So if your servo motor works, good for you, and thank you for watching this video. Goodbye.